Welcome to The Explainer. We're diving right into something I absolutely love talking about today. We're going on a journey to really wrap our heads around the vast scale and, frankly, the totally shocking contrasts of our solar system's major planets. It's super easy to look up at the night sky and just think of planets as glowing dots. But the reality? Our cosmic neighborhood is completely split down the middle into two wildly different realms. Each side has its own extreme geology, crazy volatile climates, and totally bizarre physical makeup. We're going to explore exactly how these worlds differ, moving all the way from the scorching, sun-baked rocks in the inner system out to the freezing, swirling gases at the very edge of the dark.
Okay, let's quickly run through our flight map for today. We'll start with a tale of two realms to establish that big divide. Then we'll hit the inner terrestrial worlds and explore their hard surfaces and thin atmospheres. After that, we'll cross the line into the outer gas giants, dig into the wild winds and deep ice, and finally, wrap it all up by looking at our diverse solar system as a whole. Section 1. A Tale of Two Realms. Drawing the line in the solar system.
When you zoom out and look at our planetary neighborhood, a massive contrast just smacks you right in the face. The solar system is essentially split into two entirely distinct camps. On one side, huddled up close to the sun, you have the inner planets. These are the smaller worlds made out of solid rock and dust. But on the other side, pushed way out to the frigid edges of the system, you have the giants. Massive, incredibly huge planets made primarily of gas or liquid. It really is the perfect dichotomy, the small and solid right up against the massive and gaseous.
To actually get what's going on in the inner system, we have to nail down what we mean by the word terrestrial. Basically, a terrestrial planet is a world made up of solid matter. We're talking rocks, metals, stuff like that. But the absolutely crucial takeaway here is that these planets have a hard surface, meaning if you somehow had a magic spacesuit that could survive the extreme conditions, you could physically stand and walk around on the ground of a terrestrial planet. Section 2. The Inner Terrestrial Worlds. Walking on rock and metal.
Let's kick things off with Mercury. It's the smallest planet in our solar system, but do not let that size fool you for a second. It is unbelievably dense. Actually, it's the densest planet out there next to Earth. Underneath its rocky crust, Mercury is hiding this massive, solid core made almost entirely out of metal, mostly iron. So it's essentially a giant iron cannonball wrapped in a rocky shell, just orbiting incredibly close to the sun's intense heat. And right past it is Venus, another rocky world, but covered in thick, toxic clouds. It just goes to show that these inner planets, even with their solid ground, can be absolutely hostile. But being small and that close to the sun comes with a pretty brutal downside for Mercury. Because it's so tiny, its magnetic field is super weak. Any atmospheric gases, like oxygen or hydrogen, literally just blow right away into outer space. It has zero protective blanket. So when comets and meteors come hurtling in, they don't slow down, they don't burn up, they just violently slam directly into the planet. The result is a fiercely cratered, heavily pockmarked surface. It is just a harsh, unforgiving place.
Section 3. Hard surfaces and thin atmospheres. From blue skies to red dust.
Now, compare that barren, battered rock to our home Earth. What makes Earth so utterly unique isn't just that it has a hard surface to walk on, but what's actually wrapping around it. Earth has this thick, 6-layer atmosphere made up mostly of oxygen and nitrogen. And it isn't just there so we can breathe. It acts like a massive planetary shield. It regulates the temperature, blocks the sun's most dangerous rays, and burns up those meteors way before they can strike the ground. Oh, and we can't forget that over 71% of that hard surface is covered in water. It's a literal oasis sitting right in the middle of the inner solar system. But if you jump just one planet further out, to Mars, the fourth planet, that oasis completely disappears. You are still looking at a terrestrial world, sure, but it is a cold, unforgiving desert. And the reason we call it the red planet makes perfect sense. The soil is absolutely packed with iron. Over a really long time, all that iron literally rusts, giving both the surface and the incredibly thin carbon dioxide atmosphere this distinct rusty red glow. Add to that the massive dust storms that sweep across the rocky desert landscape, and you've got a pretty wild environment. And right here is where our own human intuition really tricks us. Mars has that rusty, dusty red look that makes it seem like a sweltering hot desert, right? Well, think again. -62 degrees Celsius. That is the average temperature on Mars. Because the atmosphere there is so incredibly thin, it just can't hold on to the sun's heat. So instead of a hot desert, it's a freezing, solid, rusted rock.
So,
We really have to ask ourselves a pretty profound question. What actually happens to the climate, the geology, the very nature of a planet when we completely run out of solid ground and push further out into the dark?
Section 4. The Outer Gas Giants, a frontier of swirling gas.
Out here at the edge of the solar system, the rules completely change. These planets, Jupiter, Saturn, Uranus, and Neptune, share some really mind-bending traits. For starters, they're built out of dense, endlessly deep layers of gas, mainly hydrogen and helium. But the absolute biggest takeaway, they totally lack a solid, walkable surface. There is literally no crust to stand on. If you actually tried to land a ship on a gas giant, you wouldn't touch down. You just sink endlessly through thicker and thicker clouds of swirling vapor.
Take the undisputed king of them all, Jupiter. Honestly, the sheer scale of this gas giant is almost impossible to overstate. It's a staggering 89,000 miles wide. To put that into perspective for you, Jupiter is more than twice the size of all the other planets in the solar system combined. And those iconic, beautiful, swirling patterns we always see, that's not ground. That's just pure turbulent layers of gas. While it might have some kind of solid core buried deep, deep down inside, it's completely impossible to see or explore. It's really just a titanic sphere of cyclonic storms and swirling clouds.
Section 5. Wild winds and deep ice. The extremes of the outer system.
As we travel out past Saturn, we hit Uranus. And here, the gas giants earn themselves a brand new title, ice giants. While it is still made of gas like Jupiter and Saturn, Uranus has a totally different composition. The big difference is methane gas, which is what gives the planet that gorgeous, vivid blue color. But definitely don't let its beauty fool you. Because it's an ice giant sitting in the deep, remote outer solar system, the data we have tells us it's virtually impossible for life, as we know it anyway, to ever evolve here. And this number right here explains exactly why, -370 degrees Fahrenheit. Uranus actually holds the record for the absolute coldest planet in our entire solar system. You combine that terrifying deep freeze with wind speeds that can rip around at over 560 miles per hour, and you're looking at one incredibly hostile freezing world. Finally, we make it out to Neptune. This world sits more than 30 times farther away from the sun than Earth does. It's dark, it's freezing, and its internal structure is just bizarre. It's basically a massive, ridiculously thick fog of water, ammonia, and methane, all blanketing a solid center that's roughly the size of Earth. It really is the ultimate remote, frozen outpost. But if you think it's quiet out there, no way. Neptune actually boasts the wildest, strangest, and most extreme weather of all the planets. You see these dark spots form in its thick atmosphere, but they aren't just normal clouds. They are incredibly violent cyclonic storms. And the scale of them? Some of these storms on Neptune are the exact same size as our entire planet Earth. Just try to wrap your head around that. A single storm raging out there that's as big as the entire world we live on.
Section 6. Our diverse solar system. One star, two vastly different realms.
Putting these two extremes side by side in your mind really brings the sheer diversity of our planetary neighborhood into focus, doesn't it? On one hand, you have the hard, rusting, cratered red desert of Mars, a frozen-over world stripped of a thick atmosphere, but with solid ground you could actually reach down and touch. And on the exact opposite end, you have the immense, volatile, churning gas clouds of Jupiter, a world of pure, unbridled atmosphere where you would sink forever, completely dwarfing those rocky inner planets in scale. So, stepping back from it all, we really have to ask ourselves, how in the world did a single star, our sun, manage to give birth to such wildly contrasting planets? From that dense iron cannonball of Mercury, all the way out to the frozen, Earth-sized storms raging on Neptune. This great dichotomy of rock versus gas shows us that our solar system is a place of unbelievable extremes. And it really makes you wonder, what other profound mysteries, what other freezing dwarf planets and strange anomalies are still hiding out there in the dark, scattered edges of our cosmic backyard? Thank you so much for joining me on this explainer. Keep looking up and stay curious.